Good morning, SuriCon. Yeah, me and Gunn, we're from Grey Nose. We're doing a talk called Abusing HTTP Quirks to Evade Detection. The sort of genesis of this talk was this spring, I think. I did a multi-hour workshop at NorthSec, which was coincidentally in Montreal as well, and did a lot of work on I've worked a lot of jobs in the past, from red hat to blue hat to whatever hats. That's not the right words. Black hat to whatever. And bypassing rules and writing rules are both things I care about. So I wrote a very long workshop and then decided to turn into a much shorter talk and realized I have so much material that I can do a 45-minute talk, but I'm just going to cover a few other things I think are really interesting. And Glenn will be chipping in throughout. So I put a quick agenda here. I'm not going to go over it. You'll see it as we go. At the end of the slides, there's a QR code. We can download the slides, and we'll also send it to Kelly and everyone and make sure that you all will get the slides. So yeah, my name's Ron. I'm a principal security vulnerability researcher at Grey Noise. I've been there for 2 years and 4 days or something. It's
wow,
cool.
You're counting. Okay.
Yeah. 2 years is a long time for me to be at one job. And yeah, in my personal life, I'm a big bird nerd. These are my two birds, Clang and Sharp. And right now we're dealing with a broken wing, which is really sad, but that's our bird in his birdie jail. And I'll let Glenn give an introduction to himself.
Yeah, my name's Glenn Thorpe. I lead the security research team and detection engineering team at Grey Noise. Ron had birds, so my closest to a bird is I like to scuba dive and shark dive, so sharks are life, I guess. I've been in the field for 20 plus years, which is crazy. It's funny. Somewhere in the audience is Chris, who randomly, 20 years ago, was an intern at a company that I was at. So it's wild to see someone that was an intern a long time ago now being CTO of the coffee sponsor at SuriCon. So pretty awesome. I got a lot to think about, but that's for my therapist.
This is Glenn.
Oh yeah. So this is not a vendor pitch, but needed to kind of set the stage a little bit. So if you're unfamiliar with Grey Noise, we study unsolicited traffic on the internet. Think opportunistic for the most part, but then we also have deception capabilities. And the overall goal of our company is really to tag and understand all of this traffic that's happening online at all times. Label what is benign, what is malicious, what is suspicious, known scanners, etc. And we have this really ambitious mission to, quote, marketing term, no attack works twice. And what we mean by that, though, is really we just want to be patient zero. We want to get hit first. We want to be able to provide intelligence around what we're seeing, and then use that data for organizations to protect themselves and strengthen their security posture with it. So in our goal of becoming patient zero for the global internet, about 18 months ago, we really had to step up our game. And that involved rebuilding our entire architecture from start to finish, and moving away from, Bree mentioned it a little bit yesterday, but we had a homegrown startup live-based SQL detection engine. It worked, it did the job for the early days, but we quickly outgrew it. And that's where we get to SuriCata. So 18 months ago, when we rebuilt our entire architecture, we pivoted to SuriCata. We've been very happy with it. But throughout this journey, we have learned a lot about how to write the rules, how the rules get bypassed based on what we're observing online. And as Ron's done a ton of work in this, he's the smart one on the stage. And we wanted to share that out to show, it's going to be really hard to write perfect rules all the time, but there's a lot of common things that we see over and over and over, and wanted to talk about that here. So why this talk? Oh, sorry, thank you. Why this talk, the defense asymmetry? There's the worn out adage, we've all heard it, which is, attackers only need to find one way in, defenders have to protect for every way in. And sadly, that's really true here. But the scale of these opposing sides is very unbalanced. And that's really just because that's the structure of how the systems that we use and our adversaries are operating. So you rarely see talks about why a detection signature may not be working just because of, usually it's focused on bad rule logic or network protocols, syntax issues, but not really because of the way that network protocols are actually being used and abused online versus the way that they're supposed to work based on the RFCs. And Ron's going to go into some RFC minutia in a second. So we're going to show why building these rules perfect all the time is not really possible, but there's a lot of things that you can do that are pretty low hanging to really up your game to take away some of those rule bypasses. So, still me. And it's not based on theory. Again, just context. All of this is based on what we've observed firsthand across our global fleet. And we see about 300 million unsolicited sessions a day. But on peak days, that can mean nearly 6 million unique IPs, 1.2 billion sessions, and we process this end-to-end globally in about 30 seconds. So as the picture, I think, really illustrates really well, you can build the systems exactly to spec. You can follow all of the, you can have all the intent in the world, but you may just miss the point entirely of what you're trying to accomplish. And sometimes that's what we seem to run into here. So now I will hand it to Ron.
Yeah, so Glenn likes to say I have two skills. One is like picking up rocks to find trouble, which I'm very good at. And the other one is automating things. I never do anything once, even. Or I never do anything twice, certainly not once. So like this is going to be a combination of both, where I'm going to show like, there's a lot of things where I've written rules and I thought, I wonder if, and then I like check and realize, oh yeah, it doesn't work the way I think it works. And oh, we've written like 100 rules, I do it wrong, now fix it. And I do that a lot. I'll get in Slack in the morning and say like, hey Glenn, I found a problem. And then Glenn has a bad day. So for this talk, it's going to be kind of about some of those things. We're going to talk about HTTP. I'm trying to keep this at a fairly basic level and show some of like the real basis of HTTP. And I'm going to do it like side by side with a demo. And if I have this little application I wrote here, which I'm going to switch back and forth to, and I'll use it to kind of show off a few things I'm talking about. In the slides, I have screenshots, and I have like red squares around the important stuff and all that. So if you download the slides later, you'll still get the information. So we're going to focus on HTTP, in part because it's much easier to talk about than like bytes and stuff. I saw talk yesterday in integers and thought, boy, I'm glad I do strings and not integers for my rules. So just to kind of prove why HTTP matters, I took the nuclei repository from Project Discovery and said like how many vulnerabilities with a CVE in this repo are HTTP? And the answer a month ago was about 3,400. And how many are non-HTTP? And it was 120. These numbers are from grep and they're from a repo. So like these could be a little bit off or possibly way off. But I just wanted to justify why we're going to focus on HTTP and not like other protocols. So I want to get into the bits and bytes and talk about how HTTP works. The browser sends requests, the server sends responses, stuff like that. I mentioned URL, query string, headers, body. We will look at this thing. So here's an example of a GET request. And this is where I'm going to switch to my demo rather than looking at slides all day. So this is a little like workshop I wrote, and I just made a little thing for SuriCon to demonstrate things. So hopefully this is readable. I went to the back of the room this morning and it seemed okay. But what you're going to see here is a few different things. There's going to be requests. There's going to be responses which come from a real server that's just running like on my laptop. And then there's going to be Suricata rules in some of these where you can either write the rules or bypass the rules. Like I said, we'll be doing both. We'll be doing red team stuff and blue team stuff and like talking about a little bit of everything. Timing wise, I think I have like 2 hours of material, so we're going to do some things faster. So this is just my explanation very quickly of how HTTP works, just to make sure everyone's on the same page. I imagine all these Suricata experts. Let's just say this is for Glenn and people like Glenn who might not understand what I do for a living. So every HTTP request you see will have like the get or post or whatever, the method. It's going to have a URI, it's going to have a version, it's going to have headers, and it's going to have a potential body, which we'll see later. When we send these to the server is going to respond with things. And this server is actually running locally, so I could do localhost 4, 5, 6, 7, I think. And this is like the server I'm hitting right now. And all it's going to say is like, the response is, it's an okay, we did good. It's a text plain content type, blah, blah, blah. We sent a GET request to this path and had these headers. And I just want to make sure that like we understand those words because we're going to talk about those words a bunch. The other thing to know is a query string. So to use a web application, you often have to send parameters. Like you're doing a search or you're doing finding an image or who knows. There's a million things you do online these days. And often these arguments are sent as a query string, which you'll see after the request. In this case, I have arg1 equals test, arg2 equals 1, 2, 3. I send the request, and it parses the query string, blah, blah, blah. It's all fine. And this is going to be like thing I talk about eventually, but like you can use %34 to encode things as well, and we'll talk about that soon. And it will get decoded by the server. That's kind of what I want to make sure everyone understands. The next thing is SuriCata. I imagine everyone here knows how to use SuriCata, which is great. In this little application, we're going to have places with requests, which is like the same request we just saw, and then a rule, which in this case is, most of the rules are going to be very similar. They're going to be alert, any, the message is going to be demo, the SID is going to be whatever, rev doesn't matter. All that really matters is this one line right now, that the http.uri contains backdoor.php, which it does. If I test the rule, behind the scenes somewhere, it's running SuriCata, and it's saying this matched. So this rule matches this. If I was to change backdoor to backdoor ABC, it is no longer going to match. Yeah, now it missed. This one's just a demo of that. It's backdoor PHP again. It's trying to match not backdoor. It's going to say doesn't match. Hopefully these results are visible. I know it's kind of low on the screen there. All right, so more slides. Oop, that way. Cool. And yeah, if you go to these slides, these are all same things I just talked about, just showed differently. The reason I talked about all this is I want to get to encoding. Encoding for a hacker is your friend. And this is like my black hat for a second, red teamer, is that like, if I want to bypass a rule, I'm going to try to figure out what kind of encodings are supported and what kind of encodings the rules support, and then try to find that way in between where the rules support one thing and the server supports a different thing. And I'm going to talk about a few places where SuriCata does really well on this, and a few places it doesn't do as well. And I didn't want to say at the SuriCata conference to say SuriCata sucks because I might get kicked out. But I think there are places that I'm probably wrong, and that you'll tell me like, oh, actually, you can just set this configuration and now it's fixed. And I'd love to know that if I'm wrong about anything. So what's encoding? So depending on how you want to count, ASCII 7-bit or 8-bit has like a lot of different characters, and many of those characters aren't visible or are ambiguous or other problems. So when you're sending a URL to a server, you can't do a GET request like the one. Uh-oh. Slide's not changing. Oh, all right. Am I too fast for it? Yeah, it's got a delay. All right. I won't switch slides quickly. All right, so if you send a GET request, it's line-based, right? So if you put a new line in your URL, it's going to be the next line and be ambiguous, and that's going to be a problem. So for some examples, this space character, spaces can't be in URLs because if you had GET space URL space version, if there was a space in there, that would be ambiguous. So spaces can become a plus or a %20 symbol. Tabs and spaces are ambiguous. They look the same. So a tab will become the %07 character. Ambiguity, yeah, query strings are separated by an ampersand and equal signs. So if you want to send an ampersand equal signs, if it was like that in the URL, it would be ambiguous. So therefore, it's encoded to %26, %3D. That's HTTP encoding. HTTP encoding is defined in RFCs. RFCs are requests for comments. I'm sure most of you are familiar with what these are. I hate reading docs, I'm not gonna lie. This is why I built applications like this one, because I'd rather just experiment than read a doc. And because of this talk, I had to read these RFCs, and I was kind of upset about that. So we're gonna look at two different RFCs. One is RFC 3986, which is the URI syntax. This one, I circled the important part in red that says, a percent encoded octet is encoded as a character triplet consisting of the % sign, which we saw, followed by the 2 hexadecimal digits with the numeric value. So A becomes %41, new line becomes %0D, so on and so on and so on. The thing this does not say, which I thought was interesting, I wonder if I can go back quickly. Load. Okay. I'm not going to try switching slides like that. What it does not say is that spaces can become pluses. That is actually defined in RFC 1866, which is the HTML 2.0 the RFC, which says that space characters are replaced by plus and reserved characters are escaped per the URL, which is the previous one we just saw. So it's a slightly different standard, which is interesting. As
The slide's still not changing.
this,
there it goes.
This is the right. Oh, you can't trick me.
No, I promise it was not changing.
That's all right. If I go backwards, it's slow. If I go forwards, it's fast. I blame Linux.
Let's go from the back to the front.
All right. So that's kind of the overview of encoding. Now let's see where that causes some problems when you're writing SuriCata rules. And this is where I'll switch back to the demo thing, which does work very quickly. This is really weird. I don't know even how that can happen. All right. So what are we doing? Yeah. So this is basically demonstrating that I already talked about this in a previous one, but we used to have command equals who am I. Now we have command equals %77, %68, and so on, which gets decoded to who am I. So it's just a demonstration that the browser or the HTTP request sees one thing and then the server sees a different thing. Now, when you're matching a SuriCata rule, this is what I think is really cool, is that the HTTP URI buffer is decoded. %77 becomes W and such. So if I match the HTTP URI buffer and test rule, it matches. Great. Where it doesn't work the way you expect is with spaces. So hello %20 world will match hello space world just fine, which is cool. The goal of this is, I made little goals for myself that I forgot about, is can you hide the space from SuriCata? And the way to hide the space is %20 becomes plus. The server sees the same thing. SuriCata's default decoding doesn't detect the plus, but by default, you can do it. And I thought that was a surprise to me, that there were payloads with a plus that were bypassing my rules, and there were payloads with a %20 that weren't. And I was like, huh, that's weird. So now when I'm writing rules, and this is the thing we were going to talk about it but didn't, is that we have a whole tool set internally for linting rules, and one of our lint checks is if you're matching a URI and there's a space in it, you have to use URI decode. The URI decode keyboard, URI decode, will force that to decode, including plus signs. And is it URL decode? I know how to write SuriCata. I'm an expert. If I had URL decode, it now detects it. So one of our many, many rules is if you're doing a URI match, you must do decode. So that's what these slides just all say, that exact same thing. The lesson that I want to give you is that the URI buffer is not decoded with plus signs by default, so always use URL decode if you want to match space. Post body. I'm Canadian. I think a lot of you are not Canadians, but there was a big Canada Post strike recently, and I wanted to touch a sore spot for us. So we talked about GET requests. Let's talk about POST requests. Typically, and I use typically in very big letters because programmers don't follow standards, myself included. Typically, GET requests are used for non-state changing functions, for searches, for downloads, for files, for whatever. POST requests are designed to do state changing functions, adding to a database, deleting something, all that stuff. It's very, 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 very common that GET and POST both work in applications. And one of the bypasses I always look for when I'm wearing my black hat is, are you matching a method and will the other method work? Because the answer is often yes. Also, can POST arguments be sent in the GET request and vice versa? PHP loves using the ambiguous things. All right, so let's switch back to the demo because I prefer demos to slides. I like typing and embarrassing myself. So this is a very similar request to what we saw earlier, where it's a post to the backdoor page. It has a cookie. It has a host. The new stuff in this one is a content length and content type. This little application by default will actually add those. So those are optional. But I want to make sure that we all see that there's new headers. So content length is 10, and the content type is form URL encoded. And form URL encoded is what we saw earlier in the RFC that I can't easily switch back to, that had the specific format for it. If I send this request, we're going to see, instead of a get body, we see a post body. And the thing I just mentioned was often you can send a get with a post body. It's weird, but it works. Nothing in HTTP stops you from doing that. But the application will possibly reject it, possibly not, I don't know. I can't help but go off track on these things because I'm obsessed with bypassing and lifting rocks. So the SuriCata rule to match this request is very similar to the previous one, except instead of URI, it's request body. So if I send that, it will get caught by SuriCata rule. So now we're matching who am I, or I changed to matching CMD. So we're matching CMD here, we're matching CMD there. I can't move to the next level until I bypass this rule. Now, the difference between GET and POST is that SuriCata does not automatically decode post bodies. It does auto decode get query strings. It does not decode post bodies. So bypass this. We all know that C maps to %63, right, Glenn? Yep. Yeah. If I send that, the server still sees who am I. SuriCon rule doesn't detect it now, which is, there's a lot of different formats for post bodies. There's JSON, which we'll talk about later. There's any kind of file format. You can upload a zip file here. It doesn't matter. So the fact that Suricata doesn't decode automatically makes sense. However, as a rule developer, I need to think about this. Can an attacker encode with HTTP to bypass the rule? So now my goal is to add URL decode, not URI decode. So to make this work, URL decode, and then everything else is the same. And that should now work. Despite the fact that it's all URL encoded, it now works, which is good. Another one of our lint checks is if you're matching a request body and it's not JSON and it's not XML and it's not whatever, you must use URL decode, unless there's a good reason not to. Sometimes you can't. All right, back to slides, and I think Glenn might have a chance to talk soon. Blah, 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 this is what I just talked about. Talked about post issues. Yeah, the big lesson is don't forget URL decode when you're doing post bodies. I have a full discussion on the labs blog at Grey Noise about this. Like I said, you'll get the slides later, but there's a whole write about it here. And we'll talk about more post stuff later, but first, Glenn gets to talk, and I get water.
Yeah, take some water. Give everyone a break. Okay, so Ron's been talking about the encodings. Maybe your head's spinning a little bit, so we'll do like a little commercial break or something here. But I want to step back and think about how these technical quirks, or however you want to think about them. I don't want to say bugs because they're not bugs, but these technical quirks can actually impact the day-to-day SOC, the analyst or the folks that are relying on these rules. And so that leads me to the false negative blind spot. So when we talk about detection engineering, most of the energy in the industry, which is understandable why, is around false positives. These are the things that, it's like, did it alert? Is it in the dashboard? Is it in the ticket queue? Whatever. But like you send a thing, you expect a thing, and maybe you move on. And it's really just kind of this endless process. And we all know about alert fatigue, right? So it's natural to fixate on these loud alerts because you want to tune out this noise. But the real story for a mature security operation is about what can fall through the cracks, like Ron is demonstrating. And false negatives, it's important to realize they don't create the tickets. They don't generate the fatigue until much later. And I'll come back to that later. But this happens because most teams are really just testing one in, one out. Exploit is as expected, performing to the RFC or the protocols, expected behavior. But then what we observe online is everyone trying to get around that. So it's basically like what happens in the Wild West of the internet. And so that's just really the reality of the unpredictable, bot-crafted, handcrafted, and now AI-crafted internet traffic that is just being spewed across the internet. So back to a really simple example for the pointy hair bosses in the room. As Ron was demonstrating, there's a rule design for /etc password, and the body of the request, depending on the rule, can be easily missed with %2f etc password. And as we know, that's a different rule depending on, or a different match string depending on how the rule is written, and that's fine. But that's an example of a false negative that remains silent. And that's why when we talk about detection engineering and think about how we approach our rule writing, false negatives aren't something that we treat as rare. They're just really existing as a silent default. And security teams really need to, or rule writing teams really need to focus and pull that into their processes as an understandable just part of the operation. And I'll come back to the fatigue part on why the fatigue is going to be there either way for alert fatigue or response fatigue. So you hydrated?
A little bit. Okay. Yeah, we're in a pretty unique situation at Grey Noise because I've talked to a lot of you this week, and a lot of people run, SuriCon is often designed to be run inline and matching real traffic against real servers. We don't really have real servers, we have fake servers. So like in the false positive, false negative balance, I think I might be stealing some of Glenn's later stuff. We can much more fall on the false positive side because if somebody's talking to our sensor at all, they're probably at least suspicious, if not malicious. So if we see traffic, we can immediately assume like this traffic shouldn't be here. What is it? So like if we're matching shell injection or something, we can generally assume that like if the parameter that is exploitable is there, they're probably trying to exploit it. That gives us a very different view of how we write rules than most of you might have. All right, so speaking of Glenn's %3f path, I want to talk about paths a bit. And when I talk about paths, there's a lot of different things with paths to talk about. And I want to focus specifically on the URI and specifically on path traversal. I told Reed at dinner a couple nights ago that I was going to steal a bunch of his memes. There's like 5 more I bookmarked on Mastodon, like in the past couple weeks, that did not make it in here because I didn't update the slides since I put these here. But I love the .. memes, and Reed, please never stop doing that. He'll be doing a talk later, so make sure you stick around. So path ambiguity. This is a place where Suricata really shines. This is where I want to really compliment Suricata because it handles paths really well. These 4 paths here, and literally infinity other paths, are all the same path, which is cool. And it depends on how the server parses paths ultimately. But generally, / and backslashes on many servers can both be used. Double slashes, triple, if you can put 10 slashes, it'll be the same thing as far as the OS is concerned. You can use // forever, and that's just the same folder over and over. You can use .dat to go to the previous folder. There's a lot of different weird things you can do with paths, and it's generally up to the operating system, not the application, to handle that. And if you're running the same application on Windows, Mac, and Linux, you might get 3 different path handling things, which is real complicated as a programmer to handle paths in a secure way. And I've done pen testing talks before where I just talk about like how to exploit path traversals in weird ways. But here's just a few examples of path traversals, or of paths you might see. I like nuclei because nuclei both causes all our problems and solves all our problems because nuclei gives us templates that show what attacks look like, and then script kiddies will download those attacks and send them against everything on the internet constantly forever. So like, I won't say 99% of our traffic, which is not at all true, but a good proportion of our traffic is just people scanning nuclei templates all over the internet. But then we have logic that converts those nuclei templates into rules. So like, they both cause and solve our problems, which I love. But anyway, my examples coming up are going to be from nuclei templates because it's easy. I grabbed the nuclei templates for a like / and a ... in the same template, and I found this one. I used a little internal tool we have that's a very simple tool, but to convert the nuclei template into what the request will look like. And that's going to be the request that we play with in the demo here. So first of all, this is the simplest thing you can imagine. Get /folder/file, match /folder/file, test rule. Hey, it matches. Cool. Now let's look at that weird one we saw. Get /folder /period / blah 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 blah. This big URL, Suricata match /folder/file. We test the rule and it matches. Suricata HTTP URI buffer specifically will parse paths and normalize them, which makes rule writing so much easier. Because if it didn't do that, you'd have a million bypasses, and that would suck. So good job there. I won't say problem. It's not a problem with Suricata. It's a problem with servers. Is that sometimes you want the ... because when the server sees the ... the server processes it. So if you normalize the path in Suricata, you're going to miss the exploit. That's where the raw buffer comes in. So if I now want to match that exploit we saw, resources // when Suricata sees resources // it goes, I know what this is. That's nothing. And we'll try matching this. That will not have the word resources in it, and therefore will not match, which is what you would expect and want from Suricata, to be clear. So that will be missed. The way to fix that is to add the .raw to this. Now we're matching raw buffers. The raw buffer is not normalized, and that includes URL decoding. So now we have fixed one problem, but we've sort of introduced another because a clever attacker might replace the, I'm trying to think of a hex code I know from offhand. They might replace the E with %65-ish. And now it's not going to match anymore because we're matching the raw buffer. So once again, we have to add the URL decode. Oh, I can't type. URL decode to this. And now it will work again. So another one of the rules we use internally is if you're matching a raw buffer, and you don't need to match the percent sign specifically. Always URL decode your raw buffers. And I think I just skipped a bunch of my own demos by doing all the things early. Yeah, now add URL decode. I've already done this. I am efficient. When we practice this, it's like an hour long, but when I actually do it, we're going to finish early. This is how I roll. All right, now that matches. Cool. And we skip one demo. Sweet. Blah, 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 normalizing, raw. Yep, that's all we talked about. So, yeah, the lesson here, and I want to make sure I do a lesson. I've been accused of people talking about how to break things, not how to fix things. So I had a goal of making a lesson for each of these. The lesson is if you want to use a raw buffer, you should, but make sure you always URL decode it. And now back to Glenn.
I have to add as well, it's kind of karma because Ron spent the first most of his career like writing these exploits, and then he comes to Gray Noise. He comes to Gray Noise, and then he's seeing his exploits that he wrote being fired back at us and has to now work from the other side. So I think it's karma. Karma is real. All right. So yeah. So as we talk about alert fatigue, like I mentioned earlier, so again, everyone's obsessed on eliminating this alert fatigue from false positives, but the stakes are higher with the false negatives. And these are the ones, like I said, that they don't show up until after the fact. It's too late. The thing has happened. The attacker's done whatever they're in, et cetera, et cetera. And that's the asymmetry that we're up against as defenders. So in regards to risk, the false negatives are just scarier. They are invisible and they just lurk until it's incident response time or forensics time. And that's whenever the fatigue then comes. So it's really important that organizations or teams focus not just on alert fatigue because it's in your face and it's very visible, but also the evasion or the false negative side, because there is still fatigue there. It's just hidden. Maybe it's outsourced to another team or to another third party or whatever, but there's still fatigue happening if you don't focus, on both sides. So it's easy to just kind of shunt that away because it's someone else's problem, but that's not the right approach. And as Ron mentioned, we just at Gray Noise, we are able to take a little bit more of a less cautious approach when we're testing our rules, because we want to be able to, we're not in line, they're not in front of production items. And so we take advantage of that by kind of testing more broad rules to see what they catch and then tune it from there. And, early on we had this, when we were doing our conversion, it was really focused on, how do we make really precise alerts? And now we have moved to not having these precise alerts, but alerts that really can eliminate an entire class of a false negative. And so that's where we focus our time on now. And yeah, I think that's it. So bring it home.
All right. I have one more section, and we have 12 and a half minutes to go, so we're doing good. Lots of Q&A time. All right. JSON. I'll talk about JSON and also a little bit of XML. JSON's real hard to match. It can be obfuscated like crazy, and we're going to see a few different ways that I think are interesting. So I took another CVE, and once again, I just grabbed the nuclei repo to find a JSON payload with multiple strings in it. And this is what I found, CV 2023-30013, which actually sends 2 requests, which I thought is kind of interesting. It does a post request to the cstecgi.cgi URL with a JSON body, and that JSON body contains a command with a shell injection in it, semicolon ls pipe or ls redirect into a file, and then download the file. When I was doing pen testing and stuff, I hated these kinds of vulnerabilities. This is a real tangent, but things that modify the file system and then don't clean it up are like, don't do that. But this isn't a talk about pen testing, it's a talk about SuriCata. So that's the CV we're going to use, and we're going to look at different ways to mangle this. And I think the rest of my talk is basically just the demos. All right, so this is just the exploit as is. I'm not running a vulnerable server, so we're not going to say it actually working. But this is what the exploit looks like. So it's exactly copy and pasted from the thing you just saw. It's got the command, it's got this, got that. And here's the SuriCata rule. Now, if I want to be real interactive, I can say, what are the problems with the SuriCata rule? Because there's a lot. I wrote this rule to be bad, and it is bad, and that's the point of this. So first of all, I think that's really silly is the distance zero. Distance zero enforces a strict ordering of the arguments such that command is followed by topic URL, and in this, topic URL is followed by command. JSON doesn't care what order arguments go in. You can rearrange things, you can add white space, you can encode, you can do all kinds of stuff. I just spoiled everything I talk about. So it's missing a payload because this clever attacker, this clever black hat, switched the order of the arguments, and for some reason we added distance 0 on the rule. I don't know why you would add distance 0 besides you used AI to generate or something and it did something silly, but remove distance 0, now we match. Cool. Next. The next thing is white space. So now our clever black hat decided to add more white space to their JSON payload. JSON doesn't care about white space. You can have spaces, tabs, new lines, etc. And JSON will completely ignore them. So when we match topic URL quotation mark colon quotation mark, there is no longer a quotation mark colon quotation mark in the URL or in the JSON body because we've added spaces. So if you test this, it misses again. Missing is bad. So how do we fix this? There's a few ways, and I'm going to do something a little bit silly to make the next demo make sense. So we add content topic URL. I'm going to add another content block here, content set trace config quote. Oh, yeah, if I ever write a rule that has an error and Glenn makes fun of me, that was our rule. So far I'm doing, well, no, I made one mistake so far. All right.
I'm counting.
You're counting. This is my performance review. Glenn's my boss, in case that wasn't clear. I'm going to add PCRE, which is not a good PCRE, but I just want to use it as a demonstration. So the PCRE is going to ensure that topic URL copy paste slash paste dot star this. This is someone trying to write an overly specific rule and making sure that topic URL and set trace config are in the correct order. And in this case, because it's a key value, they are going to be in that order always. So this is a safe-ish thing to do order-wise. It introduces other problems though. So we'll see this still matches, which is good. I'm just going to copy this for the next slide because I think I did it a little bit differently. So now, new lines. Our clever attacker has added new lines. They added topic URL colon new line, which is completely legal in JSON and will completely work, but now our rule is going to fail to match. Now, this is the one I think is a little bit subtle. This, when it first started happening to us, I didn't know why this was happening. And as I mentioned earlier, I don't read documentation, so I didn't learn from documentation. I just had to fuss with things until I figured it out. The thing I learned that was surprising to me is that the dot character on SuriCata's PCRE engine does not match new lines by default. So dot star will not match a new line unless you use the /s modifier. And that is in documentation. I found out later when I was like figuring out what was going on, but I didn't know that initially. So that is one way to fix it. RTFM, yes. The other way to fix it that is probably slightly better is to use /s to match space characters. Dot star can be anything. /s will only match spaces, and spaces includes new lines. So another one of our lint rules internally is if you're doing a PCRE with a dot in it and a few other characters, it must have the s modifier. Otherwise, you miss multi-line things. So the last one, and this is the one that's real hard, and like maybe someone's gonna tell me there's a decoder in SuriCata for this and I didn't know about it, but like \u encoding works just fine in JSON, and because I have like 6 minutes left, I'm going to prove that by opening Ruby interpreter, requiring JSON, and doing JSON.parse on that string. Where's my paste button? Oh dear. I need to use single quotes. Oh, what have I done? I am in a... Okay, we're going to a new terminal. Let me do this again. Quotes inside quotes. This time I'm going to use JSON.parse and use single quotes, which I think will actually work. If this doesn't, we're just going to go home. All right. Yeah, so make this bigger so it's a little bit easier to read. So if you use this JSON string with \use and parse it with Ruby's parser, or any parser typically, you will get back the original. So \u encoding is completely valid, which is weird because this is like, I think that drives me crazy is that Ruby's JSON engine hates UTF-8 if it's invalid, but it can still \u decode, whatever. This is like my bane. I'm so sick of encoding issues in Ruby. Anyway, that will still work, and this will miss it. And unless you're doing a really crazy regex or something, I don't think there's any way to really match this payload. If I was writing this for work, I would just remove the whole body thing and say, if they're If they're hitting this URL, they're probably being naughty. I don't care. So that's kind of that. It's real hard to mesh that. This is XML, but this is an example of a rule that one of our vendors wrote for us, and like they want to match all variations of XML, and this is what they gave us. And I'm like, are you serious? Do I need to read this and understand this? But yeah, it's tough. So anyway, we're done. So the lesson is that you've got to be really careful with matching JSON. You have to understand that JSON can be encoded multiple different ways. It can have new lines and white space and stuff like that. Regexes don't match new lines by default, and \u encoding is real hard to match. And like, if there isn't support for that in SuriCon already that I'm not aware of, maybe I should have been at the roadmap session last night and suggested it. So that's the end of our slides. I don't know if Glenn has anything he wants to talk about to wrap it up. Oh, he does actually, because we have this little plushie that so far hasn't been stolen, but I'm sure it will be. And this QR code here is our slides, if you want to see our slides, and we'll share them as well.
Yeah, so QR code for slides. Our contact info is on the screen as well. If you have questions, follow up, etc. And then just a quick plug: if you're interested in running a sensor at home, but it won't look like it's from your home, and it's on anything that's hardware in your home or business, I don't care where it is. Anyway, come by the booth. We have these cool hardware kits to give out that you can take home as long as you pinky promise not to turn it into like a Sega emulator or something. But to be clear, this is alpha, like hot out of the oven. Engineering is still pushing, like it's very fresh, but it's our next thing, and we wanted to invite researchers and the SuriCata community into testing it with us. And like I said, the last 18 months have been a journey for us as a company, and we were happy to come to SuriCon, present or submit to present and get accepted and sponsored, just as a token of appreciation for the work that so many before us have done that have allowed us to kind of find these quirks and try to make the world better or safer.
And I should also mention, like, we have a booth. Bree and Brendan are at the booth. Bree is on my team as well. She also works with me and for Glenn, and she understands all the stuff as well. So if you have any questions, bother her. And thank you so much.
Yeah, thank you.
We have a couple of minutes for questions if you have questions. I think that was the speediest slide run I've ever seen, gentlemen.
I mean, that's
Oh, geez.
plus demos.
I'm glad you didn't tell me ahead of time.
But they were done before the speaker dinner. I want to be clear.
We're not going there. Okay.
I think there's a question over here, and it's making me nervous. Oh, sorry. Oh.
Hello, thank you for the nice thing. For the JSON U encoding, I wonder if the Lua transform is already merged that could do the decoding. That's the way I would do that, right? Is it merged? In version 8.
Oh, nice.
And would you want...
We're on 802, I think.
Yep.
Yeah.
Would you want a JSON decode as the URL decode transform exits?
Cool. So there isn't one, but we can write one easily now. Is that...
There is the Lua transform where you can run the Lua script, so the Lua script can do the JSON decoding if you want.
Cool.
But maybe you want something that is not Lua, so
yeah,
I guess it's easy to do such a transform as like that.
Yeah, that'd be cool.
Thank you.
Check out the Red Mine tickets. We've submitted some.
Perfect. I learned how to get things done is by complaining about it to the people who write it. Who knew?
And if you say Lua, Bree appears, who has the mic now, so that can't be good.
Yes, Bree.
Hi, Ron. It's Brianna. Did you know that SuriCata has a really fantastic read the docs page? It even has a search thing for the function you're trying to use.
I had no idea. Thanks, Bree.
Any other questions? Awesome. Well, thanks again. Oh,
Hold on.
Uh-oh.
just kidding.
Thank you for this talk. I think it was really interesting. Maybe it's the first time I really have seen a talk about people really deliberately bypassing SuriCata or similar technologies, I suppose. So I think that's really interesting. Do you think that the attackers are really paying attention to Suricata and to perhaps like emerging threats rule sets and to see like, okay, what do they detect, and then slightly change it so that it no longer detects?
Absolutely.
I do.
You're about to send Ron on a rant. Yeah, you're about to send Ron on a rant because I don't know. We can't turn this into an AI discussion in 18 seconds, but AI is, there's AI slop. To your point, I mean, we are seeing, rule sets coming out, especially if they're nuclei or open source, freely available. And then people like, oh, I'll just have AI, blah, blah, blah. And then we just see the failed attempts of the AI slop. So there's absolutely attention to it. Now, you don't know what you don't know, right? And that's what we seek to find. But yes, there's definitely skilled attackers, maybe not the script kiddies, that are focusing on like what are the detection rules that are out there, maybe community driven or something, and then change it up to bypass.
Yeah, like I've worked as a pen tester. I came from a like offensive security background, which I think most of you probably here are probably defensive security, which is it's a cool distinction. And a lot of the time I would spend like a customer would hire us to look at their network, and we would hit a web app firewall, or we'd hit like application whitelisting, we'd hit antivirus or something. And a lot of the jobs that they would pay us for is, can you bypass our WAF? Can you bypass our antivirus and stuff like that? And we would try to find ways to do it. And if you go to talk like Black Hat, DEF CON, NorthSec, which is here in the spring, you'll see talks about like bypassing different technologies. I've never seen them specifically about Suricata, but as that mindset, when I wrote Suricata rules, I'm like, I wonder how you can bypass these. And I started like finding ways. Or like I would look at our traffic log and say like, we have a tool called SIFT that will use machine learning anomaly detection and say like, this is an interesting payload that is not matching any tags. What is it? And I would say, that is absolutely matching a tag. Why am I not seeing this tagged? And I would look into it and go like, oh, it has a new line and we're not matching new lines. And it wasn't always intentional. Sometimes it was just the line wrapped, and now we're not matching .star anymore. And I'm like, oh. And I just started collecting these, and I wrote down like, not to scare you, but I wrote down like 50 or 60 of them, and did like just like a talk. I gave an 8-hour workshop in 2 hours, and showed people some of these, and they thought it was interesting. And I was like, I should talk more about this. And then when SuriCon came up, I thought this would be a great topic to like talk about with SuriCon people.
And on the labs blog, on the URL, Ron there's a blog, or there's more than one, but there's one that kind of goes into some of these examples as well as from real world experiences that we've seen. And it's funny copy paste, empty new lines, etc. Like it's.
Thank you. Great.
Yeah.
Could you speak real briefly just about the different products that you guys offer at Grey Noise, and then specifically also, can you the signatures you're working on writing, is that something your customers can subscribe to, just like a feed of Suricata signatures if they
You're
want?
backing up. The second question for the feeds, we don't at this moment. We don't share our feed. I mean our rules. That's one. Like every rule we have is written any. So Godspeed if you. But that's because again we have a different kind of viewpoint. The premise of Grey Noise is we have the global sensors, and we intentionally attract attackers for that through deception, getting them indexed into inventory services, stuff like that. Observe what happens, who does it, where it's coming from, enrich that data as much as we can, and then that's the output that we sell. That orgs can you can make a block list of it, you can do whatever, enhance your queue or get rid of tickets, whatever. But I don't want to do a full spiel here. We can talk after, but
No, thank you.
Suricata signatures is not something you guys sell.
I'm sorry.
You don't sell any feeds of the Suricata signature.
No.
Okay.
I think the message is go visit them at the booth.